Do grade 10. Pretty sure it didn't take too much. All right, so in grade 10, you only deal with right angle trigonometry, right? Triangles look like that. We're going to review that, but in grade 11, we deal with a non-right angle trig. Okay? This is a short unit. It's the last unit, because this is the last week, basically. I'm not sure which day we'll write the test, but it'll be Thursday or Friday, one of those days. Okay, so, SOHCAHTOA. Everybody remembers that. So, I don't know, every teacher writes it sort of differently. I write it like this. What does that mean? What does the S mean? Sine, or sin, because everybody drops the E. It's actually the sine. What's O? Opposite H is? What's C? Cosine or cos? What's A? Adjacent. Tan, opposite over adjacent. Okay? The only trick to doing right angle trig is labeling the sides correctly. If you can label the sides correctly, which is the first step in every question, then you will get it right. So, whatever angle you're given or you're asked to find, the opposite side is always directly across from it, right? As if you were standing there and you looked across, there's your opposite side. The adjacent is always right beside you. And the hypotenuse, we all know, is the longest side or the one directly across from the right angle. Okay, and it never moves. The opposite and the adjacent can switch depending on which angle you're at. So if I have this triangle here, and I'm standing at this angle, the opposite is this side, and the adjacent is this side. Okay? But the hypotenuse never moves. And then you also deal with, because it's right angle trig, we can use this formula, a squared plus b squared equals c squared, which is the Pythagorean formula. Exactly. Okay. Let's flip to the second page, please. Calculating angles. So does everybody have, you will need a calculator. You will need a scientific calculator for this unit, okay? So here's our triangle. It's a right angle triangle because we have this little right angle indicator there. We're asked to solve for angle X. What's the first thing you do to the triangle? Label the sides. This is the opposite. This is the adjacent. And that's the hypotenuse. I hate that they tell you all this stuff. Okay. Then you look at the side you have, or the two sides that you have, and the angle that you're trying to solve for. What two sides do we have? We have opposite and adjacent. Using SOHCAHTOA, which ratio or which trig function uses opposite and adjacent? Tan. So it's tan of our angle x. The angle always goes with the tan or the trig function, sine, cosine, or tan, equals, tan equals what? What side over what side? Opposite over adjacent. Then you just fill in the blanks. So tan of x, opposite is 6, adjacent is 5. Now, how do you find the angle? So how do you solve for x? Yes, you have to. When you're trying to solve for the angle, it's called the inverse, and you'll learn what the inverse actually is in Math 12. But for now, you just use the tan to the minus 1 button. So you're going to be x is equal to tan to the minus 1 of 6 over 5. So you're going to have to hit probably a second function, or I don't know. Everybody's calculator is different. Oh, and what mode must your calculator be in? Degree mode. So in the corner of your calculator, it should have DEG. The answer is 50.2. So if you got that, your calculator is in degree mode. If you did not get that, you either hit the wrong button or you're not in degree mode. Did everybody get that? This is really important. You will get every question wrong if you're not in degree mode. Okay. And in grade 11, you only ever use degree mode. In grade 12, we use some other stuff, but for right now, it's just degrees. 10 to the minus 1, 6 over 5. We good? All right. Okay. We have a telephone pole. It is 12 meters high, supported by a wire, 14 meters long, fixed to the top of the pole and the ground. Draw a sketch. Okay. What shape do we always deal with in trig? Triangles. So we draw a triangle. Here's our telephone pole, 12 meters. The wire is 14 meters long. Where does the 14 go? On the hypotenuse, exactly. Calculate to the nearest degree the angle between the wire and the ground. So what angle am I trying to find? Yeah. This one right here. And I'm going to use theta. That's a lot of times instead of writing x, they'll write theta for angles, especially when you get into math 12 and calculus. But you could write x if you really want to. Doesn't matter. Okay. What do I do? What's the first step? Label the sides. So what two sides do I have? I have the hypotenuse and the opposite. What trig function involves opposite and hypotenuse? Sine. So remember, SOHCAHTOA. Sine is opposite over hypotenuse. So we go sine. What always goes with the trig function? The angle or the degree, right? So whatever the angle is here, in this case it's theta, equals opposite over hypotenuse. Our opposite is 12. I mean, you can put the meters in if you want, they cancel out. Over 14 meters. How do I find the angle? Yeah, you do the negative thingy. So theta is going to be sine to the minus 1 of 12 over 14. Which we're going to the nearest degree, so round to the nearest degree, 59. Is that okay? All right. On to the next page. Calculating the sides. We're going to do, yeah, we'll do this one. No, we'll do both of these. Okay. Hate how they do this. Okay, so they drew the triangle slightly differently, just to mess you up. Right angle is still there. This is the angle we're given. We're trying to find x. What's the first step? Label the sides. So if that's the angle we're given, that's where we stand. What is x? What side is x? That's opposite. 17 is the hypotenuse, and this is adjacent, even though we don't really need it because it doesn't give us any information. And now we're trying to find, we're trying to find the opposite. We have the hypotenuse. What involves opposite and hypotenuse? Sorry? Sine, right? What always goes with the trig function? The angle. So sine of 49 is equal to what? What side over what side? X over 17.6, opposite over hypotenuse. All right, sine of 49 is some number. I don't know, you got to punch it in your calculator. I have no idea what that is. .75, I'll just round to 2 decimals. Everybody agree with that? So that is 0.75 is equal to x over 17.6. How do I solve for x here? That's it. Multiply the 17.6 up. Equals x equals 13.3. Is that right? Or something close to that? I think it's in meters. Is that okay? Sorry? Because the actual word is S-I-N-E. Everybody just drops the E. Okay, same thing. Here's our angle. We're trying to find A. What side is A? Hypotenuse. What's 24? Adjacent. What involves adjacent and hypotenuse? Cosine. Angle always goes with it. And it's adjacent over the hypotenuse, so it looks like that. Okay, you have choices here, depending on what you'll want to do. You could first convert the cosine 73 into a number, which is cosine 73? 0.29. And then to solve for it, what do? That's, you switch them, but why can you switch them? Because this is why, you're correct in what you do, but a math person would not like that. So you'd multiply both sides by A, those would cross out. Now you have A times 0.29 is equal to 24. You divide off the 0.29. So you get A is equal to 24 divided by 0.29. But the shortcut is just switch the A. But that's why you can switch them, okay? Because you're actually multiplying by A on both sides and then dividing by 0.29. 24 divided by 0.29 is 82, 82.1, something like that. 82.8. Oh, okay. So we'll round to 1. 82.1. The other way you could do it, it's the exact same thing, but it just looks a little different, is because we know that's a number, we could just write A is equal to 24 divided by cos of 73. And then just go 24 divided by cosine 73, and you'll get the same answer. All right? instead of converting it first. I don't really care what you do. All right, we're going to solve this triangle, then I'll give you a couple practice questions, and I'll email your test scores back to you. So, we got to find the lengths of AB and AC. All right, right triangle. I want to find the length of AB. What do you want to find first, AB or AC? It doesn't matter. You want to find this side or this side? All right, AB it is. So we'll just call this X. Okay, here's our angle. Label all the sides. What is side X? Opposite. 109 is the adjacent, and this is the hypotenuse. Okay. We're finding AB. What side am I trying to find, and what side do I know? I know I'm trying to find the opposite, and I know the adjacent. What involves opposite and adjacent? Tan. So it's tan of 74 is equal to the opposite, X, over the adjacent. Tan of 74. 3.49. So then just multiply the 109 up. What are we going to? Nearest foot, so 380. People agree with that? So this is 380 feet. All right, now what? So you have choices now, right? You want to use the Pythagorean theorem? Is that what you want to do? Okay, because we know two sides and it's a right angle triangle, to find this side, AC, which I'll call it Y, okay? I can use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. When you're using the Pythagorean theorem, what is the only thing you need to remember? What's the key here? Does it matter what A and B are? What's the only thing that matters? C has to be the hypotenuse, all right? So in this case, that's going to be y for us. So A and B doesn't matter. We can just go 9 squared 380 squared is equal to y squared. And if you do all that, I'm going to get 156,281 is equal to y squared. How do I get y? 395. That's what I'm going to do in a sec here. Because you can do it that way too. If you do mess up the opposite, yeah, you'll get it wrong. But so you can use the Pythagorean theorem, but you can also use trig. This is the hypotenuse. You know the adjacent. So that's cosine. So you could go cos of 74 is equal to the adjacent 109 over y. And then go y is equal to 109 divided by cosine of 74. And if you do that, I think you get the exact same thing of 395. Or pretty close. If you really wanted to, you could use that. And that would be opposite and hypotenuse. And you could use sine of 74. I'm not going to do it, but you could do this. Sine of 74 is equal to the opposite, which is 380 over y. And that should give you y is the same thing, 395. There's 3 different ways to do it. But if you have 2 sides of a triangle, a right angle triangle, you can always use Pythagorean theorem. Does that all come rushing back from grade 10 math? The good times that were grade 10? 2 to 4, please. And then we have one more thing from this lesson, and then that's it for today. Okay, just thing that kids like about Trig, or maybe they don't like about Trig, is it has all these applications, which means there's all these word problems. All right. So we have a tree that is being held up by 2 wires. One of the wires makes an angle of 48 degrees with the ground. So the other is 12 meters long and makes an angle of 56 degrees. Both wires are attached 3 meters down from the top of the tree. So they're not right at the top. There's 3 meters. And so, boom, this one makes an angle of 48 degrees with the ground. The other one makes an angle of, whoa, that's a bad line. 56 degrees with the ground. And it's 12 meters long. And this bit here is 3 meters. Okay. How tall is the tree? That's what they want to know. Sorry? Bigger than 3 meters? Okay, well, let's find out. So we only know right angle trig right now, so we're going to drop a line right down the center. I can find this distance here because I know this side and this angle, so I can find this distance. What is the first step when you're doing right angle trig? Label the sides. What side do we know? What side are we trying to find out? Trying to find the adjacent, and we know the hypotenuse. What involves adjacent and hypotenuse? Oh, what am I doing? That is a good question. Why are we finding the adjacent? I was doing another question. Sorry. In my head, I don't know what I was thinking. I want to find the height of the tree, so I want to find this, right? I don't know why I was doing that. Sorry. We still know the height. I'll call this x. So this is the opposite. That makes way more sense when you're trying to find the height. Okay. What involves opposite and hypotenuse? Sine. So sine of 56 is equal to the opposite, which is x, over the hypotenuse, which is 12. So what's x? I'll let you tell me. We'll go to 1 decimal place, please. What's the answer? 9.9. Is that the height of the tree? What do you have to do? Add 3. So 12.9 is the height of the tree. All right. C, part C. Determine the length of the other wire. So I want to know that. Why? So we're going to use the other half of the triangle, which I'm going to redraw here. I know this is 9.9. I know that's 48. I want to solve that. What sides do I have / want to know? Opposite and hypotenuse. What involves opposite and hypotenuse? Sine. So sine 48 equal the opposite over the hypotenuse. Which is 13.3. Everybody agree with that? Okay, last question, D. How far apart are the two wires? Right, so I want to find this distance, I'll call it A, and this distance B. So you're going to use each individual triangle to find those two distances and add them together. I'll redraw the triangle down here. That's 9.9. That's 12. That's 13.3. 56. 48. I want to find A. That's the adjacent. What side? You have a choice. Well, you have three choices. You could do trig, and you could use either the 12 or the 9.9 to find A. Or because you know two sides, you could use Pythagorean Theorem. And then you can do the same for finding B. I'm going to let you figure it out. I'm going to freeze it. I'll do it. I'm going to do trig, but if you want to use Pythagorean Theorem, it's your choice. Remember, multiple ways to do it. I just did trig on both. And then added the answers together. Your final answer should be about the same. It might be slightly different due to rounding, but if you're like 15.6, 15.4, anywhere around there, it's right. Is that good? We okay? We just did math 10 trig in 45 minutes. All I want you to do is number 6, please.